Alright guys, for today I'm only going to go over one example, example 5. It says, say it is known that a sine of alpha is equal to 1 over the square root of 2, which, if we simplify it, is equal to the square root of 2 over 2. And that alpha is between the square root of 2, pi over 2 and pi. So between 90 degrees and 180 degrees. And we also know that sine of beta, so here's a different one, is equal to negative 1/3, and that angle is between pi and 3 pi over 2, so between 180 degrees and 270 degrees. Find the exact values of each of the following: cosine of alpha, excuse me, cosine of beta, cosine of alpha plus beta, sine of alpha plus beta. Alright, so the first thing we're going to do here to find the cosine of alpha is we're going to use our, what I would do is I would just use the Pythagorean identity. But one of the other things that I'm thinking about here is, in this particular case, I kind of know what the answer is, because if we're at square root of 2 over 2, I know that's at a 45 degree angle, right? But since we're between pi over 2 and pi, that has to be at 135 degrees. So we're at 135 degrees, which they did draw a picture of, so I guess I'll use their picture here. They drew a picture of it right there. So I know what the x value is at that place. It should be negative root 2 over 2 without doing much work. But say it wasn't a nice like that where I knew that. How would I find it? Well, you'd go back to your definitions. So 1 over the square root of 2 is equal to y over r, because this is a sine function. So I know I have a y value of 1, okay, y value of 1, and a radius of square root of 2. Okay, so what I can do with that now is I can look at that triangle, right, where this is 1, this is the root 2, and I can try to find what this x value is. Okay, so to do that, I can just simply say 1 squared plus x squared. Maybe I'll move down to the next page here. Well, here it is. So we have 1 squared plus x squared is equal to the square root of 2 squared, which is just 2. Then I can solve that thing, and I get that x is equal to 1, right? Because the square root of x squared, this gives me actually plus or minus 1. I know it's the negative 1 because I know I'm over here, right? So all the x values over here are negative. So I'm going to use negative 1. Okay, so now I can use my cosine, the cosine definition, and I can say, okay, that's the same thing as negative 1 over root 2, which comes out to negative square root of 2 over 2. Okay, so it's basically just using the Pythagorean identity to come up with this stuff. So and then they say alternatively we could use, our identities here. We know that the cosine squared of alpha is equal to the negative root 1 minus, we say negative because of where it is, but 1 minus sine squared of alpha. They just basically solved for cosine in our identity that we've already talked about. I encourage you to do it the Pythagorean theorem way, but whichever way you want to is fine. For part B, it says the sine of beta is negative 1/3. Okay, well, that means that I have a y value. Oh, and it's important to know where we are. We're in quadrant 3 because we're between pi and 3 pi over 2. So we're over here. And we have a y value of negative 1 and an r value of 3. I know that the y value is the negative because the r value is never negative. Okay, so it's negative. It's either the x or the y that's negative. So let's take a look here. They want to know what the cosine of beta is, I believe. So to find the cosine of beta, I basically have a triangle there. That's a 1 by 3. So I can say 1 squared plus x squared is equal to 3 squared. So I get x squared is equal to 8. Take the square root of both sides, that comes out to 2 root 2, and since we're in this direction over here, the x value is also negative, so it'll be negative root 2, negative 2 root 2. Okay. So, now that we've established the x, we have to go back to, this is what they're doing here, we have to go back to our definition, right? So the cosine of beta is x over r. So we have that x is negative 2 root 2. The r value here is 3, and I am done. Okay, so for part C, the last two parts here now are, can we use what we just found to plug into our sum and difference formula? So do I know what the cosine of alpha plus beta is? So again, we go to our definition of sum of, well, it's I guess it's an identity, but go back to the sum of a cosine. It's cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. So I now know the cosine of alpha, and I know the cosine of beta. Okay, so I'm just plugging that in. We just found them, right? So we just found these guys. Plug them in here, and then we do a little bit of combining like terms and multiplication, and let's see what we come up with. So square root of 2 times the square root of 2 is just 2. 2 times 2 is 4. Okay. 2 times 3, negative 2 times negative 3 is positive 6. So we have 4 over 6. Okay, and then we're going to subtract. So we're subtracting here, so be careful with your signs. Subtract square root of 2 times negative 1 is negative root 2. And then 2 times negative 3 is negative 6. So if we're subtracting these negatives, it becomes addition, right? Then we combine like terms here. We have 4 plus square root of 2 over 6 for cosine of alpha plus beta. Do the same thing for sine, right? So sine starts like this. I'll let you guys finish this up. I don't want to take too much more of your time. But sine of alpha plus beta is sine of alpha times cosine of beta plus cosine of alpha sine of beta. Remember, the cosines line up here in the middle. And that is the end of this lesson. I'm going to let you guys go with that. If you have any questions, please don't hesitate to reach out, and we'll talk some more about this in class next time. All right, take care, guys.